Hello, welcome to the next episode of The Workflow Show. This is episode 402. I am your co-host, Nick Gold, and I am joined by my fellow co-host, Jason Whetstone, also of Chesapeake Systems.
Hey guys, how's it going?
And of course, we have our ever-reliable producer, Ben Kilberg, also Chesapeake's Solutions Architect.
Howdy.
Here with us. And joining us today, we have a guest from outside our organization. It'll be a little less of the typical echo chamber of the Workflow Show. We have Chris Bailey, who is the CEO and co-founder of the makers of FileCatalyst. So FileCatalyst, a lot of our clients actually utilize or know about. It is a file transfer accelerator technology, which is kind of a mouthful. We're going to certainly talk about what that is, both the technology and the challenges it addresses in general, and then we'll relate that to kind of FileCatalyst itself. So thank you for joining us today, Chris.
Great to be here, and thanks for having me.
Absolutely. So you're Skyping in today. Where are you Skyping in from?
I'm Skyping in from balmy Ottawa, Canada.
Ottawa.
Where it is 95 degrees right now.
Wow. Seriously?
No. It's probably like 45 degrees.
And is that Fahrenheit or Celsius? Because
That's Fahrenheit. I'm adjusting this for your audience. So.
It's really for us because we have no idea.
Yeah, it's like 6 degrees Celsius, I think, something like that. It's cold for this time of year.
Yikes.
So there could be snow here in a few weeks. They're talking about flurries on the weekend. So
Whoa.
Right.
it goes from pretty warm to pretty cold pretty quick here.
And here in the Mid-Atlantic, or in our Baltimore hometown today, we're having like this really nice spell of autumn.
day,
It's like
yeah.
it's just gorgeous, Chris. Ideal. Really, really.
Hang up now.
You're missing something.
I don't know.
So is Ottawa where you guys are based, or is this just where you happen to be located at the moment?
We are based in Ottawa. We're all true Canadians up here, all based in Ottawa.
So you are one of the founders of the tech that we all know the brand of as FileCatalyst. Tell us about kind of just yourself, a little bit about your background, and what brought you into kind of decide to create a company around accelerating moving files around on the internet.
Well, I graduated with a computer science degree from Dalhousie University. Not sure if anybody's heard of that. It's on the east coast of Canada in a town called Halifax.
Yep.
And right out of university, I was recruited, and I was working for the Canadian government for a while, and met my now business partner, John Kuchevsky, and we started collaborating in our spare time on some file transfer technologies. It wasn't accelerated. It was based around FTP. So what we did is we made a Java applet that can run in a web browser that did FTP from your web page. So instead of having to go around and install FTP clients everywhere, you could install an applet on your web page that would allow all your users to simply browse in and upload and download their files. So that's how we kind of started out, and then we decided to quit our day jobs in the government and do it full time. And it started to evolve. We had a lot of companies like print shops, graphic design houses start using the software, and they came to us and said, hey, can you allow us to submit some form data and metadata along with these files? And can you make it a little simpler to use? Don't have the classic two-pane FileZilla look. Just make it an upload. And so we started to make customized forms for people, and these features just started to evolve into products. And that kind of is the first generation of our company from around 2000 to 2005 was, web-based widgets for submitting online files. We started to notice around 0405 that there was a real uptick in the amount of media and broadcast customers coming in. And this sort of coincided with the move from tape to digital and the move from SD to HD. So files were getting larger, and it was a real hassle and cost money and took time to ship hard drives. And at the time, a lot of people are still shipping film in the movie industry. So, we had customers come to us and say, hey, we really like your stuff, but can you make it go faster? We were using FTP, as I mentioned. So we had to come up with a way of doing the same thing we were doing, just as easy to use, but do it a lot quicker. And that's when we started to look at our acceleration technology, FileCatalyst.
Right, and FTP is, it's a stands for File Transfer Protocol. For those that don't know, it's been around for many years.
When FTP is, I think, a 70s technology, if memory serves.
Yeah, the original protocol for file transfer protocol was written back in the 70s, correct?
Right.
Yeah. So, and it's interesting to hear you say that even in your earlier days when you were building basically a web-based, Java applet, FTP uploader, concerns around workflow because of your creative base of users it seems like that was baked into your culture early on because they're giving you feedback like, well, we don't necessarily need every last feature. We need this to be as efficient as possible so it fits into the workflow of a typical creative outfit as they're passing files along to get a job done.
Exactly.
I just think it's interesting that, from the get-go, essentially, those were some of the concerns that you found yourself addressing. It's not just throw every technical capability at the wall. It's how do we do this in a way that makes using this fundamental technology as smooth and easy as possible to fit into the workflows of a creative professional set of users.
So, Chris, talk about some of the problems with FTP that you ran into that caused you to want to move on beyond that.
Well, the problem with FTP is it's based on TCP, which is also a very old protocol, but it powers everything that you're using now on the internet.
TCP, when we think of the internet, most people are thinking of TCP/IP,
Correct.
which is Transport Control Protocol and kind of melded together with the original internet protocol or IP.
Right.
So how does that work? Why is TCP not as ideal for sending a file across the internet when TCP seems to power the vast majority of services on the internet?
Well, TCP was built to not cause the internet to collapse with congestion. So it's very quick to, if you're sending a lot of data, back off when it sees that other data is attempting to go through. So it plays very fair with other protocols. There's a lot of protocols out there like that you'd recognize, HTTP, for example, FTP, obviously, SFTP. Almost everything, is built on TCP, and they all have to coexist on the internet, and you only have a finite amount of bandwidth. So really, it was built to allow everybody to coexist at one time. And when you started to see packets lost, it interprets that as there's congestion, let me slow down quickly. And in addition to it has a speed up mechanism that relies on sending bits of data across called a TCP window, and that's a finite amount. What happens is it sends some data and then waits for a reply, and as geographic distance grows, sometimes it's sitting waiting for replies more than it's actually sending data. But it does that to avoid these types of scenarios where there's a lot of congestion and everybody's applications start to slow down. So what happens is, back in the 70s when this was originally conceived, and over time there has been iterations to improve the performance, it might not have been forethought that we'd be dealing with gigabit networks or 100 meg plus, and now gigabit at the home sometimes.
Sure.
So it wasn't really designed to handle the bulk file transfer we're seeing now with, high definition 4K or uncompressed video or audio files, or even now people snapping pictures with their new iPhone. You quickly fill up your storage. If you got to move those, you're moving them across, using a transfer protocol that uses TCP. And so it's quite slow. So when you start getting into businesses, organizations that need to move this type of data around, they have massive amounts of data. They have big bandwidth, but FTP or TCP-based protocols just can't move the data fast enough. It just wasn't designed for it.
So basically, there's a lot of this handshaking going on between the multiple nodes that are communicating with one another, right?
And FTP is very sensitive.
It's a sensitive little protocol, and it's very fair and egalitarian, but sometimes, your data just wants to kind of sit in the corner and do its own thing.
Easy. We don't want to hurt its feelings. It's very sensitive, as you said.
And again, this really comes down to kind of what the internet was originally built around, which was kind of reliability of getting the data from point A to point B at all costs, and a willingness to maybe sacrifice immediacy for that to happen, right? And it was also kind of this very egalitarian view of the world where all the bits should kind of be considered, equal to one another, and we're sending them around, and they're all going to be patient and wait on one another. And It's going to kind of, what is it fair to say, almost kind of self-shape the traffic based on that very egalitarian approach. But once that's just happening all the time and you really need to get your big frickin' file from, your office to, say, a colleague that needs to review a video, that just starts making it go slow for you despite whatever bandwidth you might have on either end, right?
Well, correct. And I mean, back in the mid to late 90s, it was actually perfectly fine, even from a speed standpoint for your average usage.
Sure.
But
yeah.
as bandwidth started to grow, or as even with smaller bandwidth, as latency starts to grow, so geographic distance, as we know now, people are becoming, and companies are becoming global, more geographically dispersed. You might be doing some editing in one location and you might be doing production in other locations. So you need to collaborate across very large distances that without the internet was impossible in the past. But now you have these scenarios. And so now with the bigger bandwidth available, bigger file size, before people didn't care if it, took an hour and a half, but now we're talking the difference between an hour and 20 hours to transfer a file with TCP versus an acceleration technology.
And this ties into a point I was essentially making it for a different set of technologies, but I was making this point to someone, a potential client I was on the horn with this morning. I said, when you look at speed and reliability, and at the time we were talking about storage systems, but I think the principle applies here. It's not just, well, I've got 100 megabits up and down at this location, and they've got 100 megabits up and down at their location, and so I'm going to send them a file, and gosh darn it, we can count on essentially 100 megabit speeds. That's not what happens in the real world, correct?
If they both have the 100 megabits, in theory, you would expect you would, but this is where the latency problem kicks in. If you're going across town, then you might actually get that 100 megabits, but that all depends on, is that link shared amongst others in your office for other applications? Is there QoS involved that will throttle you back and not allow you to send that fast? If you had a clean network, across town, very low latency, then yes, you might be able to saturate that 100 megabits.
But what if I have an office in New York and we've got an LA office, so it has to jump across the public internet across a continent, but I still have my 100 megabit up and down in each location? What starts to actually be the real world experience when you're hopping across cities, continents, states, oceans, etc.?
Well, let's use your 60 to 70 millisecond latency there. That's from LA to New York approximately. And what's going to happen with that is you're going to start to get the chit-chatting is going to become a bottleneck. So as Jason was mentioned earlier, it's a very chatty protocol, FTP, and I mentioned the TCP window, the chunks of data that get sent across. Now when you're reaching that type of bandwidth, you're sending a chunk of data and you're waiting for the reply. If you look at kind of the network graph of this transfer going on, it's going to be very spiky, a lot of peaks and valleys, because the valleys are going to be waiting for the replies and the peaks are going to be sending more data. So as the geographic distance grows, you're going to see more valleys and less peaks.
Ideally, you want to see as flat a line as possible that comes as close as possible to your maximum theoretical bandwidth.
Sure.
And at the moment you're having these moment-to-moment drops because of this handshaking and these confirmations that are constantly occurring, even though you're peaking out maybe at decent speeds, it's like if you're trying to drive your car down the street and you're having to kind of like go from 60 miles an hour to 5 miles an hour, and you can only do 60 for 5 seconds at a time. It's like, that's just not an efficient way of driving down the street.
The difference between driving down the street on the highway versus on a parkway where there's lots of shopping malls.
Yep. And I have a great analogy that I like to use for this, and this will get into UDP a little bit, and that's it. Let's say you're trying to fill up a swimming pool and you have a bucket and you're sitting there by the hose bib on your house and you fill up the bucket and you can dump it right into the pool and you keep doing that. That's great. You're right beside it. You're getting that water in there as fast as you can. Now let's push that pool, 100 feet away, and you have 2 or 3 people in between. Now you fill up your bucket and you only have one. You have to pass it to the next guy. He passes the next guy or girl, the next guy or girl. Dump it into the pool, pass the bucket back, you fill it up. Wouldn't it be more optimal if you could have multiple buckets? You fill one up, pass it along, fill one up, pass it along. There's a constant flow of buckets going across. Now, it wouldn't make much difference when the pool is close to the hose bib and you can just dump it right in. But as you get more and more distance and you need more and more people and you're passing that one little bucket across, that it's going to fill up the pool slower and slower as you get further away. Whereas if you're sending a constant flow of buckets across with water, really it doesn't matter. Once the first bucket starts to reach there, there's always going to be another bucket to dump in. So you're going to be filling up that pool just as fast, even if it's far away, as if it's close. And that's kind of what we've done with FileCatalyst with the UDP protocol is we're sending multiple pieces of data concurrently with the other pieces while we're waiting for the first piece to be acknowledged. We're sending the second piece. We're sending the third piece. And so all those valleys that you see as the distance grows with TCP-based protocols like FTP, we're filling them up by just sending more data at the same time.
So UDP, we were talking about TCP, and the most things we do on the internet are built around TCP. What is UDP, and how is it something you're able to use on the internet if so much of what we do on the internet is based on the TCP, Transport Control Protocol?
Well, I'm assuming that a lot of your listeners are technical people and they've probably played
I wouldn't assume that.
games. Well, a lot of people play games and a lot of watch streaming video.
Sure.
And so if you've done those things and you've played online gaming, a lot of that is using UDP in the background. And what UDP is great for is streaming. And it's good for real-time applications where if you lose a couple packets here and there, the packet is just a piece of data that's being sent across. It's not going to be the end of the world because you can recover from that. It's real time. It's lost. You don't need to get it back. Whereas with a file, typically you need every bit of data to arrive.
What does UDP stand for again?
A user datagram protocol.
God, and that was actually an earlier protocol than TCP, correct?
Right. It's kind of a precursor, and it doesn't have all the congestion control and the flow control that I was talking about earlier that stops the internet from kind of collapsing as you're using. As if everybody was using UDP at one time and with unbounded, they just send it as fast as they could, then immediately everybody would kind of grind to a halt. So you really have to be careful when you're using UDP and applications built on it like games or streaming utilities. They can stream at the exact rate that they need. And they need to have some sort of mechanism to throttle things back as well. Go ahead.
Here's a question. I mean, you were talking about streaming video and that if there's packet loss, when I'm watching a streaming video, say it's Netflix on my computer or on my TV through my Apple TV or whatever it is, yeah, sure, we're all used to those moments where suddenly, it obviously steps
Breaks
down
up
in
a little,
quality,
yeah.
or you get some, macro blocking artifacts when obviously it's taken a hit on the data rate. You get some weird visual distortions for a moment, and then it kind of snaps back. And, that might be annoying as a user, but it generally these days doesn't dramatically hold up your enjoyment of whatever you're watching. But you said that would be bad if you're transporting a file because a file needs to be intact at both ends. It needs to be the identical set of bits as it was on the transmission end as it is on the receiving end. So this seems contradictory to me. How can one use UDP with this kind of almost shotgun approach? And maybe some of the bird shot's gonna hit it and some of it's not, but it kind of doesn't matter if the bulk of it hits. How do you reliably send files using a system like that?
Well, the nice thing about UDP is that you can send at a perfect stream, so you get that flat graph. But as you mentioned, you can lose packets along the way. But the nice thing about file transfer is that you don't need to have every packet arrive in order. You don't need to have it arrive until later in the file potentially. So if you build a system on top of UDP that can track what's arrived at the destination and what hasn't, then concurrently while you're sending new data, you can be retransmitting any lost data. As opposed to TCP, what it does is it will sit and wait because it makes sure everything arrives sequentially. So if something's lost with TCP, it'll actually stop transferring, send a negative acknowledgement, which is, hey, I missed packet 9, resend packet 9, and it will not progress. It doesn't have the concurrency built in to do that. So we've had to build on top of this unreliable UDP protocol a retry and retransmit mechanism that happens concurrently while we're sending that flat line, that smooth data stream across. And so because of that, we're able to send at any speed essentially we want to reliably, just like TCP would, but we since we've added our application level features to retransmit and retry these lost packets, we don't have the same issues that you would if you were just using raw UDP.
But
So
that's
this is
still, oh, I'm sorry, but that's still not adding the kind of overhead that would be associated with a pure TCP transfer, right?
Exactly. There's still some things that TCP would do, but like the congestion avoidance and that sort of thing that we've also had to build on top. But we do it in a little bit less aggressive way than TCP would. So, I mean, we still have the same problem where if you want to send data across the internet and it starts to encounter other data, let's say someone else on your network is just browsing the web and they start downloading a file, well, we still have to slow down to allow that traffic to go through. But we at least allow you to tune how much to slow down. Do we want it to be aggressive? Do we want it to be passive? And so we've also built that into the protocol that we've kind of built on top of UDP to allow that to happen. So we allow you to be almost as aggressive as TCP slowing down, or way less aggressive, and we can slow down to basically nothing when we see other traffic and then speed back up. So we've essentially created our what we think is almost a better version of data transport protocol than TCP ever could be,
Right.
because we've started from scratch and tailored it specifically for bulk data transfer.
Yeah, and the application, the FileCatalyst application, is very flexible in that regard. It's very, tweakable, and you're able to really kind of use all the bits you can in your stream and your bandwidth.
So how does that end up manifesting? So give us, some back of the napkin kind of scenarios. Like, what do your clientele who have been, let's say, just using an FTP client across the public internet, which many of our clients still do constantly, they're using technology from the 70s, essentially. Sure, it's attached to a much bigger pipe, but it's like, well, if you have the biggest pipe in the world and it's still like a gerbil and a ball at one end, it's not going to do that much. So, like, when people who have been using FTP, for distributed file transfer, start to utilize this UDP-based file transfer acceleration technology that you guys have baked into the FileCatalyst product line, what happens to them? What happens to their data? What happens to their world? Like, are we talking about something? Do they get an extra 5%? Do they get an extra, is it twice as fast? I mean, how does it play out?
Well, let's go back to your LA to New York scenario, because everybody is aware of LA and New York. Like I mentioned,
they're the two biggest media markets in the U.S.
Well, there you go.
A lot of distributed work groups. Our own clients have offices in both those locations. Sure.
So between those two locations, you'd have a typical round trip time or latency of 60 to 70 milliseconds. And just as an example, if you're sending a 10 gigabyte media file from LA to New York, it could take 5 or 6 hours on a 100 megabit connection with FTP. It depends on if it's tuned, it depends on what operating system you're using, but you'll get a steady transfer and get it there in about 14 minutes with FileCatalyst.
Wait. What? I mean, that's not like 5% or 20% faster. I think you could just say that's like way faster.
Well, some people, like when we go to a trade show, for example, we have kind of a billboard we stick up that has these types of numbers. And of course, we take a extreme number. And keep in mind, if you had a 1 meg file, then it might be 14 or like a minute and then 2 minutes with FTP. So you don't see the difference. But when you stretch that difference across a 10 gig file, then it starts to really stretch out the FTP transfer. Whereas since we get that theoretical maximum speed across the network the entire time, we're able to get it there in the theoretical minimum time possible with that given bandwidth. So, and it really depends a lot on, you can go into your registry and tune all these things with TCP, tune the window size, and both sides have to do that. So if one side hasn't done it, then, and if one side's Linux and one side's Windows or one side's Mac, they might get better performance than others. But in general, you're going to get those types of performance gains. And if you go into gigabit speeds now, you're not going to get much extra speed with FTP. So you could be upping your bandwidth from 100 megs to a gigabit, for example, and it's taking you that 5 hours to get it across, it's going to take you the same 5 hours to get it across. Whereas
because the bulk of what you're waiting on are these constant reconfirmations in the communication
and all the
protocol.
hops. Yeah.
exactly, I mean, the latency, the network RTT is not going to change. So your bottleneck is not the bandwidth at that point. Your bottleneck is that latency in between. So, but with FileCatalyst, it doesn't care about that. So it will immediately claim all of that extra bandwidth. So when you're getting into, the 10 or the gigabit speeds, then you're talking, a minute or two for the same file would take 5 hours with FTP.
That's tens and tens and tens of times faster.
Yeah, I mean, and now imagine taking those types of bandwidth and stretching it from LA to Hong Kong or New York to, Sochi. Or Ottawa is actually pretty close to New York.
Yeah.
But if you're going,
in Canadian terms.
in Canadian, there you go. So yeah, if you stretch it further, you're going to Asia, you get like 200 milliseconds of latency, then yeah, the speeds are just ridiculously slow with FTP. I mean, it becomes unusable. I mean, everybody's familiar with the concepts of mirror sites for downloading. What the traditional scenario would be to remove this download bottleneck is to just mirror the content to other download servers around the world,
Sure.
and you download from your local,
whichever one's closest.
Whereas with FileCatalyst, you could have one server in the world and everybody could just download at the same speed.
And again, I mean, if you're Akamai or Netflix and you have edge servers placed at all of the key internet sites, these actual facilities that are the main nodes that all of the internet traffic goes through, sure, edge servers might be a perfectly reasonable way of distributing your collection of, say, movie files or content for whatever the big broadcaster is, and sure, make it so everyone in the big cities can be grabbing something locally. But that's not how workflow tends to work in post-production.
Really,
we're going point to point. It's literally these guys in this office have created this unique file that literally just hatched into existence at that moment. And of course, what do our clients always want? Like immediacy and everything, because they're always up against deadlines. And so that one file that only exists in that one place needs to go across the country or the ocean or whatever it may be. And they just need it to get there. So you're saying that there's probably a lot of people dramatically overpaying for bandwidth that aren't getting a lot out of it if a lot of file transfer is what they're up to if they're not using FileCatalyst.
Well, that would be our main return on investment right there.
I mean that could pay for itself in like a week.
Wasted time, wasted bandwidth. I mean, you get a file from A to B, and then person at B says, "Hey, that's not the right file," or "No, I need you to redo this." Well, if you can shrink those bottlenecks down, it takes you only 15 minutes to send a file as opposed to another 5 hours. You can have that kind of back and forth. Hey, can you review this? No, do this, resend it. And you can do that. It makes it possible within the span of a few hours. Whereas with FTP, you better get that file right the first time.
Sure.
And what's interesting is, what we've seen in our industry, I think, in that, let's say, call it the last 10 or so year period where things went very file-oriented from baseband video signals or tapes, and file sizes have obviously increased. But as the internet has, expanded in our lives and in our infrastructures, it's allowed for people to be more geographically isolated and still kind of be part of the same work groups. What's happened as well in that time is we see a lot less people that we deal with in these environments who are kind of dedicated media management people. It's usually the frickin' editor or the creative or a producer who's also having to do a lot of these types of file management and movement tasks.
It's not the IT people or the...
And they don't like having to just do this type of rote stuff over and over. And if it takes 5 hours to transfer a file and it was the wrong one, their head is gonna explode when they have to do it again because they'd rather be editing. They'd rather be cutting or doing graphics or putting together their next package that they're working on. So, again, the fact that it tends to be only somewhat technical creatives who often are tasked with these types of exact things, I think it's just all the more reason why you want it to be simple as possible. You want it to be super reliable. You want it to be super fast so you're not bogging down creative people and throughout their day with these types of tasks versus, the creative stuff you're probably actually paying them for. and you've found a way to make the technology just work much more optimally. Well, I mean,
So,
it's great.
Chris, talk a little bit about what goes into this. Like, so what do we need to make this happen? Is this software? Is this hardware? What's involved?
Well, it's 100% software, and we have two kind of avenues I can talk about here, and I guess we can get to both. To start with, we have our off-the-shelf products, and what that looks like is, if you're familiar with FTP and how to deploy it with the client server, it looks just like that. We have a FileCatalyst server, which has user accounts that you can create with home directories. You can create groups that include multiple users that can have virtual folders, and so everybody kind of gets access to what they need. They log in, they see a file system just like they would with FTP. In fact, you can connect with a third-party FTP client to our server as well and transfer just fine with FTP if you want to.
You
But
won't,
then-
you won't see the speed.
Platforms,
You
right?
won't see the speed benefit, of course.
Correct. But
Right.
if you plug our server in place of your FTP server and then replace specific strategic nodes or locations with FileCatalyst clients, that's the route that some people do take. They don't want to necessarily change the experience. Some people like it or they don't need acceleration. But that's kind of the server side of things. And then the client side, we have a few different options. And the client side is the one that's sending and receiving files to the server. We have all the way down from an API and SDK where you can build your own applications to a command line tool just to kick off via a script or manually transfer files to watch folder applications that they can just watch a folder where you're saving your data from your editing studio, and as soon as it sees that file, it can start sending it across the network. And then we have web applications, so you can browse into a web page and use it directly in a web page. So we have a wide variety of different applications to actually deploy this.
Sure.
So
And platforms, I mean,
yeah, I was just
Linux,
about to ask.
Linux, Mac, Windows, all
That's
that.
that's it. You've hit it right on the,
Okay,
the nail
great.
right on the head. So all those platforms.
Commodore, Amiga,
Yeah, we run on Apple IIe.
Atari ST.
BOS. No.
Vic 20. So
Sorry.
started to date ourselves there. But
Yeah, well, we're
Atari
all-
ST was the one that came with them built-in MIDI ports. I had two of
Oh
those.
yeah, that was great.
we're working on our TRS 80 port.
Yeah. You load the software off of like an analog cassette tape.
That's right.
The bottleneck starts to become the analog cassette, right? It's- There's only so much you can do to accelerate that. I mean, fast forward, helps a little bit, but so you have client side applications that are thick client apps. You've got web-based applications, so there isn't even really something that the client side needs to install. You talked about your server stack a little bit. Again, we're talking about software that runs on a physical server that you've built out to be a file share server, but that uses the FileCatalyst technology. What platforms can that run on? Is the server also a cross-platform technology? So it could be anything from a Mac Mini with a Thunderbolt hard drive on it all the way up to like a burly Linux server running, Red Hat or something like that. I mean, what are the options there?
Correct. I mean, all of the above. It depends on your usage scenario. I mean, you can run it on a laptop if you want to. We have a lot of, server side, generally you could run it on a laptop, but generally people would have that on like you said, a beefier server. But the client side application, the watch folders, we have news gathering, agencies that are out there in the field with a laptop with a 3G connection, and they have a watch folder on the desktop, and they use that to send over cellular networks back to the server. So you don't really need a beefy piece of hardware. We also have Android and iPhone apps that you can go and get in the app stores. And so, I mean, it's running on cell phone hardware. So it doesn't have to be beefy. When you get into the very high speed, you get into the 10 gigabits plus, then, of course, you need to have the high-end machines to do that, the high CPUs, high-end storage connected with fiber to be able to handle all the reading and writing.
Sure.
So yeah, it just depends on your needs. It scales all the way up or all the way down.
I'm actually interested let's talk about cellular for a moment, because one of the trends that I see quickly coming together, and you really just spoke to it yourself, and a lot of typical, traditional ENG, electronic news gathering type, setups where you might have a microwave truck or a satellite truck, And that vehicle literally has one of those towers on it, and it either does line of sight microwave, or maybe it's even a satellite dish bouncing off of a bird somewhere. And those ways of beaming video content from a remote news gathering crew or production crew or sports production crew in a sports broadcast environment, was typically done kind of as real-time baseband video signals, traveling in real time across these links, again, going between a truck and a microwave transmitter, or a truck and a satellite and then another facility. And it was very oriented around kind of, we can beam this back in real time, not really any faster. And it costs a hell of a lot of money to do that. You're literally talking about satellite time, or you're talking about very expensive microwave hardware and towers and all sorts of crazy stuff. This move to utilizing kind of off-the-shelf cellular networking technology that we obviously have literally swimming around us and going through us at all minutes of the day at this point, because the internet is literally kind of in the air all around us. That I think that's a very interesting trend. And so this idea that not only can you use the off-the-shelf cellular technology opposed to these much more expensive and proprietary transmission technologies is fascinating, but you run into the same kind of latency issues because, again, you're often using the public internet at that point, right?
Oh, correct. And you hit also packet loss issues, especially as you're moving between cell towers. You're getting away from one, you're going to have a lot of packet loss. And that's a big issue with, as you mentioned, with satellite or wireless technologies, even Wi-Fi. As you're getting farther from your router, you'll notice that the speed kicks down, starts dropping down. It can't negotiate as high a speed. But that's because of interference, and that manifests as packet loss when you're transferring files. And packet loss is interpreted by TCP or FTP as congestion, even though in this case it's not. It's actually interference. TCP interprets it as congestion and will throttle your speed way back. So when you're using a cellular network now, several years ago it wasn't as big a deal with 3G, for example. It was slow enough, but as you start to get into 4G LTE, now the speeds are getting to the point where that speed limit, essentially from TCP, because of the interference and packet loss, is causing you not to be able to transfer at full speed of your LTE network. And that's where technology like FileCatalyst on a mobile app, for example, or just running on a laptop but using a LTE or 4G modem, that's where you're going to start to see speed gains as well.
That's this whole idea that there's kind of a logical limit to what those traditional transfer technologies can give you, no matter how much raw bandwidth you have. That's like my big takeaway here, because it's like, guys, you can pay for 100 gigabits, but if the protocol itself or the physical layer of the technology you're using has these inherent limits to it, you can pay for as much bandwidth as you want, but it's essentially wasted money. And one of the technologies that I love hyping that is we're just on the threshold of is what I call the real first true 4G cellular technology, LTE Advanced. And LTE Advanced is really still very much in testing phase, even though the latest iPhone, like the 6S, for instance, has an LTE Advanced baseband chip in it. But LTE Advanced in the next 3-4 years, we're going to be having hundreds of megabits worth of connectivity to our cellular devices. And so this idea of leaning on cellular networks more and more for this type of stuff, it's going to fit into this exact scenario. Even though the network is much faster, if you're using these old school protocols that are subject to various types of issues on them, you're just not taking advantage of all of this advancement in bandwidth and connectivity. So these things become, it's funny because, again, this is kind of the opposite of my thinking going into this conversation. As the raw bandwidth gets bigger and bigger, it actually becomes more important to have these types of technologies at play. It's not like the raw bandwidth obviates the need for them. It's like the raw bandwidth even creates more of a need to take advantage of the bandwidth. That's like huge light bulb for me, because I didn't really think of it that way.
No, and that's exactly why, as a acceleration company that's using this type of technology in our products, we're excited because we see the future. We're seeing files grow. They went from HD to 4K to now 8K content's going to be starting to move around, and we see bandwidths growing, but these protocols aren't changing. The speed of light is not changing, so latency is going to always be there, and there's always going to be some sort of interference that causes these packet loss. So, technology like FileCatalyst is it's well positioned for the future. Just getting it into the hands of the people that need it is the big challenges for us.
Yeah.
Well, we'll talk about the commercialization a little bit more in just a moment, but there is another point I wanted to make. You had talked a little bit about, you used the phrase APIs, and you kind of spoke to that. You have an implementation of the underlying FileCatalyst technology that can kind of be baked into other systems and become part of more sophisticated workflow management systems. So at Chesapeake Systems, one of the most active areas that we're involved with literally every day, and Mr. Whetstone here is essentially one of our workflow engineers who is doing programming within media asset management and workflow automation environments like Levels Beyond Reach Engine or a number of other platforms. It could even be like Telestream Vantage. And we love hooking those types of software platforms into kind of other pieces of enabling software technology through application programming interfaces, hooks that those third-party software makers make available, so we can kind of have the software directly talking with each other versus having to rely on things like watch folder workflows, which not only require more manual input, but you kind of, in a workflow that you're tracking, you kind of can lose track of things a little bit when things are hopping between folders. We like to have very central management and understanding of where things are at in any given workflow that's unfolding. And when the software is very deeply integrated to another software platform through APIs, we get that capability. Can you talk a little bit more about how FileCatalyst, amongst some of your clients, has been fit into these types of overall kind of workflow management platforms or media asset management platforms?
Sure. I mean, we've spent probably the last 3 years trying to build up an ecosystem of technology integration partners. And those range from asset management solutions to workflow management, storage and archive, QC, transcoding. So in order to do that, we really had to put a focus on not our off-the-shelf features, but on our integration features, so our APIs. And we work closely with various vendors of these applications to see what they need, what kind of hooks do they need into our technology in order to just sort of drop them in and plug them in. And so we have an extensive, it's called a REST API, and it's sort of a web-based technology that any web browser could even call one of these URLs, the same URL used to get to a web page. We expose our technology through a series of URLs that another program can call and kick off a transfer. The part of the URL says, hey, transfer this file from this location to that location. Here's the credentials. Here's how fast I want you to do it. And then you can call another URL that says, hey, give me the status on this transfer that I just started. Mm-hmm. And so using these types of hooks, third-party tools, workflow management solutions, asset management solutions can now kick off transfers directly from their own application, start it up, send it to where they need it, get the status. They can show a nice progress bar back inside their application, and they get the file from A to B as fast as possible, whereas previously maybe the default application that it used to transfer files was FTP, so that would essentially be what we refer to as a file transfer bottleneck inside someone's workflow. So maybe someone has to send a file into a workflow, then it goes somewhere else for transcoding, and then it needs to come back, and there's 3 or 4 transcoded files that need to be sent somewhere else. Every time that file needs to move, if it's in a different geographic location, it's a file transfer bottleneck. So if you have FileCatalyst software deployed in these locations, now you're just telling it to send between FileCatalyst servers. Now you end up with as fast as possible, at least in terms of the file transfer part of things. We obviously have, there's complementary technology like transcoding, and they can become faster in different ways. But for us, just reducing those file transfer bottlenecks is our focus, and providing APIs like the REST API that I just mentioned to our customers. In order to do that is kind of been one of our focuses, and we've built up a large ecosystem of vendors that probably you guys have heard of in order to accelerate those workflows.
Yeah,
So
which is awesome. That's what I spend a good part of my day doing is picking these APIs apart and figuring out how we can
You probably
use them.
dream in REST, APIs at this point. Get it? When you're when you're resting. No,
the other part of my job is listening to Nick.
So the enjoyable part. So here's another light bulb that just went off in my head, Chris. We've been talking a lot in this conversation about, very kind of point-to-point transfer. Maybe you got an LA office and a New York office, or New York and London, or New York and Singapore. What about the cloud? And when I say that, I hate the term the cloud, frankly, but I think it's just been overused and watered down, and it's kind of like Web 2.0. It just sort of became meaningless.
Rid of it.
But the cloud does actually kind of mean something. And when I think of the cloud, I think of services like Amazon Web Services, the actual idea that you're using someone else's physical IT infrastructure in their data center and essentially just provisioning as much of it as you kind of need at a given moment. And hey, you're kind of getting a lot along with that. They're handling a lot of, file backup and disaster recovery and high-speed links and all of these things. And you just pay for it as a service as needed. Can you, and you mentioned transcoding, right? So we work with some vendors now, like Telestream that has Vantage Cloud, and then of course there's encoding.com and people like that. And of course Amazon themselves also just bought Elemental, the transcoding company. And so obviously they're making even more investments in web-based transcode, and Amazon in fact already had offered cloud-based transcode as a service. Can we put FileCatalyst nodes on someone's cloud infrastructure? So if you're creating content locally and for the foreseeable future, you're going to have to kind of do that heavy lifting post-production locally. But let's say you need to do a lot of transcoding or very fast and you don't want to build out a huge transcoding cluster. Can we kind of put FileCatalyst at our local side of things and FileCatalyst kind of on the cloud, if you will, so we can kind of really expedite that process of moving files from our local infrastructure to the cloud to do some type of operation and then bringing it back at a much faster rate than we normally would have if we weren't using FileCatalyst?
Of course. Why would I say otherwise? No, in all honesty, we have Amazon is simply just running VMs. It's Windows and Linux, and you can install our software on any Windows or Linux box. But beyond that, the storage that's used in the back end, for example, if you're using Amazon S3 to store those files and use maybe your encoding is happening directly on the files in Amazon S3, well, FileCatalyst server software is able to map user accounts directly into your S3 account. So it will appear as a regular file system at which you can then accelerate using UDP from your local location into FileCatalyst server, landing in an S3 bucket that's maybe being used by your transcoding software to transcode, and then you can then pull the files back down directly from S3. So we've done a tight integration using all the Amazon's REST APIs into FileCatalyst to make it appear as a nice file system when in fact it's a bunch of blobs sitting there. And using that kind of approach, you're able to essentially accelerate files in and out of cloud, not just the cloud and the local storage, but in and out of the actual cloud storage. And we have a very similar offering for Microsoft Azure as well. So you can actually upload and download files directly into the Azure Blob Storage and then download files directly from Azure Blob Storage. And any services that you use that are based on top of those storage services from Amazon or Microsoft can then access those files. So that would be kind of our cloud integration at this point.
That's wicked, and there's all this talk of the blob, and we should probably do an object storage episode soon because
That's not a bad idea, Nick.
Because we ourselves are talking object storage more, and many people don't really know what object storage is, and
Right.
Object storage is not the traditional little file system with a hard drive icon that you just connect to and mount, and it you have folders and subdirectories. It's not necessarily a new paradigm, but it's a very different paradigm in in file storage. It can still be utilized by transcoders and as part of, the repository for things as part of an overall workflow. But having that accelerator on one hand to get to it and from it, if you're using, say, Amazon's S3, and then on the other hand, the tools you give to kind of treat that object storage a little more generically, a little more traditionally, if you will, so it's maybe a little easier to fit into certain types of workflows. That sounds like just a critically enabling technology that makes the cloud just significantly more usable in these types of media and video-centric workflows than it would otherwise be.
Right.
Yeah, and in addition to the, just getting access, the traditional tools that Amazon or Microsoft provide are all based on an HTTP-based REST API. So,
right. So
if you were to have
REST calls,
exactly, it's an HTTP-based upload which has the same bottlenecks as FTP. So, by putting us in front of your S3 inside EC2, which is Amazon's compute area, then you've taken that part that does the REST calls and you put it on a very low latency network. So that bottleneck kind of disappears as much as we can. And then the long haul part that's from your office into the Amazon infrastructure, that's the part where we do the acceleration. So without us there, then you're starting to move a lot of data in. It's going to be very slow. And Amazon does have an import-export service. They just released a new version at their reInvent show in the last week called Snowball. And what that is they ship you a big storage appliance, and you can install an application locally to move all your data onto the Snowball appliance and then ship it back to Amazon, and then they'll put it onto S3 for you. So that's their solution. Yep. Well, I mean, it's funny when you think about it, but some people need to move petabytes of data.
Sure.
So
no.
With the bandwidth available today, even with FileCatalyst, it's going to take you weeks and weeks. So to a point, I can see that. But the funny thing is that they don't provide you a way to get that data back out. And there's a reason for that, because they want your data to live there forever.
Exactly.
So FileCatalyst allows you, within a reasonable amount of time, with reasonable data, to get the data in and out in the optimal amount of time. And that's not possible with the APIs that they've provided.
So let's talk about we talked about a number of different types of organizations that can use FileCatalyst, but again, let's just relate this to the actual product line a little bit in terms of costs and who this might be appropriate for. Is this something that just inherently is going to cost someone tens and tens of thousands of dollars, and a certain segment of the market it's not going to be appropriate for, given the costs and complexity of setting up FileCatalyst? Or do you have kind of something for work groups of all sizes if they have this need?
So our software is all pretty much bring your own license. So it starts from a couple $1,000s and goes up into the tens of thousands of dollars, and depends on how many servers you want, et cetera, et cetera. But it's targeted generally from all the way from SMEs up to large enterprises. I mean, so you can have small post houses that are using it, all the way up to one of our largest on the media side would be NBC Sports, who used it for the Olympics. But then we have it across verticals. We have a company like Dell using it enterprise wide. So it's really it can scale down, and really where the ROI comes in is, as you mentioned earlier in the show, you're paying for this bandwidth, and you're paying a lot of money every month for this bandwidth. So you got to look at it and say, I'm spending maybe $500 to $1,000 a month on this high bandwidth connectivity, and I'm not able to utilize more than a fraction of it. And I need to get this file from A to B. So you're recovering money from the bandwidth costs that you're spending, but also what about that lost time and productivity? So that's where you sit down and you do an analysis and say, you know what, to get a perpetual license to this software, this is going to pay for itself within 4 or 5 months, and then I own the software.
Or, I mean, again, if you're getting tens of X improvement in transfer speed, you might say that gigabit internet link that we have is way overkill, and maybe we only need 100 megabits because now we're actually taking advantage of it. It's way faster than it was before, even with the gigabit connection. We can just cut back on our bandwidth bill. I mean, I imagine in many circumstances, it more than pays for itself essentially instantaneously.
Yeah, well, the productivity alone, I mean, how valuable is that to get the almost instant feedback? So, yeah, there's many ways it can pay for itself, but we do understand that there are even smaller companies who can't even afford the initial capital cost. So they're looking for something on a pay-as-you-go basis, maybe per gigabyte or per transaction. Or so we do provide monthly subscriptions as well. And we do have, several partners that we work with. One of them is called A-Frame, for example, and they provide cloud services, for these types of situations where you just pay per gigabyte as you go. And we have several partners of that kind of ilk that we've partnered with to provide those types of services. That's not to say that we won't come out with something in the future that kind of it's FileCatalyst branded and it's off the shelf, just pay per gigabyte, maybe ties into your cloud storage. But for now, we've partnered with several others to do that kind of the lower hanging, to get it to the masses.
Sure.
Type.
Sure, but it really does sound like for the type of clientele that we deal with across the board, it could be a mega media corporation or it could be a smaller production company with a few different field offices. It sounds like you absolutely have something that we can be putting in for those clients of ours, and it's not going to necessarily break the bank. In fact, it could be, again, a massive, almost immediate return on investment. So let me ask you this. We don't work with them directly, but we do encounter a few other folks in the file transfer acceleration market who are somewhat well known as well. You I think tend to kind of be lumped in with them as one of the best known for these technologies. What would you say makes you guys unique?
Yeah,
I
what
mean, just
sets
as
you off from the competition? I would
both kind of just the way you approach the technology, the set of tools you have, maybe the price points and your offerings. Why FileCatalyst when someone is starting to say, I'm going to explore this thing. This sounds useful. Why might I go with these guys?
Well, one of there's two main competitors that you guys are probably aware of, and one of them has shifted more to the cloud side of things, and they're offering more of a SaaS offering. And while the other one, we'll call them IBM.
Yeah, exactly.
They're IBM now, so that's one reason not to work with them. But leading up to that, I mean, it's very similar technologies in terms of the transport, but where we differentiate is we feel is the feature set. So, and that's not to say that they have a bad feature set or ours is better, but it depends on the scenarios. What we've chosen to focus on with ours is easy to use, tight applications for our off-the-shelf products, and then partnering with several industry experts in different areas like workflow, immediate asset management. So we're focusing on making the technology able to integrate with the masses, whereas they've focused on building their own versions of workflow management and orchestration and that sort of thing. So
right, that's really important. Yeah.
So I guess it's kind of seems like almost a closed ecosystem versus an open ecosystem. We're kind of...
You want to specialize in the part and be experts of your domain without having to expand into all of those ancillary areas. Let's make it as easy as possible to hook into us. So you don't have to use, well, we can just say it, Aspera, which is owned by IBM, has a product called Orchestrator, and it is kind of a workflow automation system. And it's like, well, maybe you want to use Reach Engine instead. And there's plenty of good reasons why a person might want to do that. And it's like, well, why get kind of pulled into an entire ecosystem of solutions when we really just need to find the perfect puzzle piece to plug into what we're doing cleanly, efficiently, cost-effectively, and let an integrator, say a Chesapeake Systems, because this is kind of what we do, put the ties together between the platforms that you choose and make it as tight as possible so you can kind of pick the best player for each component of your overall solution and tie them together in a way that, frankly, a lot of the time is more integrated than the so-called vertical stack coming from, a more integrated solution provider. Because, frankly, they can't be good at everything, right? You guys can be really, really good at file transfer accelerator technology for either an individual user or as part of an automated workflow, and then let people have a lot more options when it comes to how they take advantage of it.
Exactly. And to an extent, our off-the-shelf products allow you to do somewhat of we call it a loose integration with watch folders, as you mentioned. To get started, if that goes well and you like it, then you can move on to taking the APIs and integrating them more tightly. So then you instead of waiting for a third-party application to pick up your file and move it, and you have no way to monitor that, now you can fire off a transfer exactly when you want it and monitor it with the API, and you can get real-time feedback. You know exactly what's going on. So providing all the different levels of options is really what our focus is on. And then, just dealing with IBM, I think it's kind of spooked a few people. So we find that our niche is as I mentioned, with the integrations, and also just being a company that's easy to deal with. Aspera has been around a bit longer than us and has grown a little bit larger than us. So because of that, they maybe won't do the things that we'll do, adding a feature here and there, or dealing directly with our developers and not having to jump through all this red tape. So we give that kind of, we can serve the large guys, but we can still act like the small guys when you talk to us type feel. And a lot of our customers really appreciate that. And that's not just the small post houses, that's all the way up to large networks. And
I was going to say the integrators really appreciate that too.
Yes,
there you go.
and I think customers want to have a relationship with their key vendors. All of our clients, whether they're small operations or mega corporations, they want to have a bond with their key technology vendors. And yes, they also want to have a good bond with their integrator or support system that Chesapeake, say, might be for them. But they also want to have a relationship with the manufacturer, so to speak, of the core technologies. And the fact that you guys are that nimbler, kind of more sociable, approachable operation is why, we've picked you as kind of our go-to to direct people to and to make part of the solutions that we craft, because that is more representative, frankly, of the type of partner that we've always found huge success with. It's those folks who are in a niche, they really understand, they are deep level experts, and you're not having to go through 5 layers of middle management just to get a basic answer or work on a technical issue or get questions solved that come up during an integration. You guys are easily approachable, and I think that's that really sets you apart, as you said. Is there anything we've missed in the conversation? It's been pretty comprehensive at this point. I think people have probably learned a lot. In fact, I know I have, and I love. That's why I love doing this, because we learn things doing this show. So it's been fantastic having you. I mean, how can people learn more about FileCatalyst? Obviously, they can reach out to Chesapeake Systems at any time, but where would you direct someone to who kind of wants to learn a little bit more about your suite of solutions specifically?
I would just say go to FileCatalyst.com. Right on the homepage, there's 3 boxes, and we try to make it really easy. Do you need acceleration? And it kind of walks through a description of what the problem is with TCP, how do we solve it, and then you can move on and see what our solution, how do we bundle that underlying transport with applications, and then if you're still interested, then we can send you a trial. So we kind of hold your hand through that process using our website, or you can just go to the menu bar and kind of go wherever you want and see. But we basically want people to be able to come in and understand what we do right away and be able to see concrete examples of how we do it, and then request a trial if they want to. So that's the best way is just through our website.
FileCatalyst.com. And again, of course, folks can engage Chesapeake Systems directly as well, either through myself or just sending something to prosales@chesa.com, or our phone numbers. Our listeners tend to know how to get a hold of us. And obviously, we can be available to consult and bring people together with Chris and his team and be part of an integration. If you want to tie this into, say, your media asset management platform, that's obviously all within our skill set, because we don't keep Whetstone busy enough writing to REST APIs. He has to do more and more and more. And this has just been fantastically enlightening, Chris. And it seems, again, for all the reasons we've talked about, we're going to just have more and more and more reasons to be working with you guys as utilization of the cloud increases in this industry, as people have bigger and bigger bandwidth available. Your need just becomes all the more singular. So thank you so much, Chris Bailey.
Thanks for your time,
founder,
Chris.
CEO
Absolutely.
of FileCatalyst. You heard him here, folks, on the Workflow Show. Thanks so much for joining us today, Chris.
Thanks for having me.
Yeah, thank you.